So today we're covering abstraction. So if you remember previously at the start of the class, I talked about there are 4 pillars of object-oriented programming, which we'll review again today. The last pillar, the first 3 were polymorphism, um, inheritance, and it always slips me. Polymorphism, inheritance, and what's that third one? Let me look real quick. Inheritance, polymorphism. Let's see. Oh, I'm not finding it. Really bad. Encapsulation. There we go. So polymorphism, inheritance, encapsulation. Those were the first 3 that we've learned this semester. And if you recall, polymorphism is the ability to pass a subclass to a method that expects a superclass, or to do dynamic binding, where you declare a variable as a superclass, but when you create it, you might create an object of a subclass. We have encapsulation. That's where you make all the fields in a class private, all the variables private, and then provide getters and setters in order to access and modify those fields. And then inheritance, that's just your ability to create superclasses and subclasses, right? Those are the first 3. The fourth and final pillar of object-oriented programming, and remember, this will come up a lot, is abstraction, okay? Abstraction is similar to, and I'll just go to the next slide. So straight from the dictionary, it's the quality of dealing with ideas rather than events. So it's abstract, right? You know, I think it does this, but I really don't know how it does what I'm expecting it to do. So for example, I gave the example of logging into Facebook, right? When you log into Facebook, there's actually a lot of processes that are initiated as a result, right? First, you're authenticating and making sure that you have the correct format for your email address and password, and then it goes off to the server. The server probably adds a little value to your password, then it encrypts it, and then it compares it to what's in the data, all of that good stuff, right? That's logging into a website. As a user, all I care about is logging into Facebook. I don't care about all that other stuff, right? And that's a form of abstraction. I know what it's supposed to be doing, logging into Facebook. I don't know what actually is going on in the back end, right? What exactly is Facebook Inc. doing with that information I passed to it, all right? So that's a form of abstraction. What we want to do as programmers is provide a class or whatever, provide a very abstract nature of that class. It has certain methods, it has certain characteristics, and we don't really want the user to know exactly what's going on. They can look at it, but it's unnecessary. All they need to know is that this class exists and they can use it. That's it. And so essentially you're providing a template of expected behavior for another programmer to use, right? So in order to accomplish this, you have 2 things at your disposal. You have abstract classes and abstract methods. Abstract classes, they, of course, in the class name, you're going to have the keyword abstract. So if we look here, I'm going to go to assignment 9. If you call assignment 9, we have an array list. We're adding, removing athletes, all that good stuff. Our athlete class, however, we're never really going to create just a generic athlete. Right? We're either going to make for my example, a basketball player or a tennis player. So we're never going to create an athlete, but there are other classes that inherit all of the characteristics of an athlete, right? So they have a name, they have a weight, they have all that good stuff. So I can make athlete abstract, public abstract class, and I'll explain what that does in a second. All right, so abstract classes may or may not contain abstract methods. So if it has an abstract method, which we will cover in a little bit, it can or it cannot. You don't have to have abstract methods. But do note, if it does have at least one abstract method, then any subclass must implement it. Plus, the class must declare it as abstract, and I'll get to that in a second. Like I was saying, you have to provide implementations to all the abstract methods in an abstract class. And I'll talk about this and give an example of all of this once I get through this. If a class is declared abstract, it cannot be instantiated, which means we can no longer create an athlete object. For example, I've made public abstract class athlete. Athlete is now abstract. So I cannot create an athlete object. I can't do this anymore. Athlete A equals new athlete. Right? I can't do this anymore because athlete, the class, is now abstract. So I can't do that no more. Since it's an abstract class, I cannot create a new athlete. That's not possible. So just note that. All right. And to use an abstract class, you have to inherit it from another class and provide implementation to the abstract methods. So for example, if we look back here, I can't do this, right? This is an error. Athlete is an abstract class, so I cannot create an object of an abstract class. However, basketball player extends athlete, so it inherits from athlete. I can still create a basketball player. Basketball player, BP equals new basketball player. I can still create a basketball player, right? It inherits the athlete class still, right? But basketball player is not abstract, so I can still create this object. Athlete, however, is abstract, so I cannot create an object of athlete. That making sense so far? All right, so the next logical question would be, why are we making abstract classes anyway? What's the point? Why are you even covering this? So abstract classes, again, you cannot create an object of it, but whoever the next programmer is, they can look and say, okay, I need to use this person's athlete class. I have a water polo player. Water polo player is technically an athlete, and so I need to inherit all the characteristics, name, weight, and height of an athlete. And then as a water polo player, they'll have additional characteristics as well. All right. But never in that program are they going to actually create just a generic athlete. They're going to create a water polo player, right? And I'll go through all of the pillars once I finish abstraction. Any questions so far about abstract classes? Why we use them, how to create them? Again, you create them just simply putting abstract in the class name, and that abstract now makes it impossible to create an object of this athlete class to instantiate it, but you can still inherit it. And any class that inherits athlete still inherits all of the characteristics. So basketball player still has all of these methods and all of these characteristics. We can just no longer create an object of athlete, okay? All right, let's continue. All right, next we have abstract methods. So if you want a class to contain a particular method, but you want the actual implementation of that method to be determined by a child class, you can declare the method in the parent class as an abstract method, okay? So for example, and then just keep going, abstract keyword is used to declare the method as abstract. You have to place the abstract keyword before the method name, yada, yada, yada. An abstract method contains a method signature, but no body. Instead of curly braces, an abstract method has a semicolon. So how do we declare an abstract method? So in most sports, if I'm not mistaken, each athlete has the ability to score, right? To score. And for different sports, that score is different, right? So for example, if I create this athlete right here, right? Generic athlete class is abstract. I can do public void score int points, right? Then I could say, let's create a points variable, private points, private int points. And then down here, I could say this dot points plus equals points. Cool. Now, any athlete can call the score method, pass in however many points they score, right? But let's say, depending on the sport, depending on the type of athlete, how they score points is completely different, right? It's completely different. You don't just add the points to their individual points. You have to spread it out. You have to, whatever it may be. So instead of providing the implementation here, what I can do is just simply this. Make it public abstract void score. It's an abstract method. If you notice, there's no longer any implementation here. I did not implement this method inside of my athlete class. However, what you'll see is now my basketball player and my tennis player have errors. And that's because basketball player is not abstract and does not override abstract method score in athlete, okay? Since athlete is the superclass, and I put this abstract method in here, any subclass has to implement that method. So if I go into basketball player, I go over here, click right here, implement all abstract methods. We scroll down to the bottom, there will be a public void score in points at override. Any child class has to override abstract methods in the superclass. So at override public void score. And so for a basketball player, for their score method, I may want to say if points equals 1, I want to say system.out.println this dot name scored a free throw, right? Get name. Else if points equals 2, system.out.println get name plus scored a 2-point shot. And then else if points equals 3, obviously, system.out.println get name plus scored a 3-point shot, right? The implementation else get name isn't playing basketball, or they're playing in the that other league, the Big Three. So if we look here, the score method for a basketball player is different, right? It's unique to a basketball player. And I spelled score wrong here. All right. For a basketball player, if they score a point, I want to say scored a free throw, scored a 2-point shot, scored a 3-point shot, or isn't playing basketball if it's not one of those three, right? That's what I want to do for a basketball player. However, if we go to a tennis player, we have to implement all abstract methods. For a tennis player, let's see, system, how would they score? 15, 30, 45, game. Let's see, for a tennis player, it's a little bit different, right? Because we'd want to look at who their opponent is and determine what the score is and print that out. So their public void score, I'm going to put in here private tennis player opponent. All right. This dot opponent equals new tennis player. Actually, no. Let me not do that. I don't want a new one. I want to pass that in. Tennis player opponent. This dot opponent equals opponent. All right. And I'm spelling it wrong. Yep. Source, refactor, encapsulate fields, opponent, refactor. All right, so now I have a getter and setter for opponent. So for a tennis player, what I want to do is, and then for athlete, let me do this as well, refactor, encapsulate fields, getter and setter for points. All right. Or score, I'm sorry. So what I want to do for a tennis player is, so inside their score method, if they score their points, right, they score 15 points or whatever, I'll just put in whatever their score is. So if they have 0 and they score, then they have 15. If they have 15, they score, they have 30. So if get points equals 0, set points 15. Right? So I'm saying if they have a 0, now they have 15 because they scored. And then I'll do else if points equals 15. I want to make them have 30 now. Another else if. And what you're noticing is the score method for a tennis player is completely different than the score method for a basketball player, right? Depending on what my use case is. I'm sorry, 40. And then else if, this is where I want to have a unique condition, get points equals 40 and their opponent, this dot opponent dot get points equals 40, right? So now they both have 40. Then technically system.out.println deuce. Then I'm going to say set points just for this 45, right? Just to say that they have a different score than them. So now I check if the tennis player has 0, they have 15. If they have 15, they have 30. They have 30, they have 40, yada, 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 right? So system dot out dot print line. Actually, let me not do that. So for each time, let's see. Each time they score, I want to say what the current score is. System dot out dot print line. This dot get points. No, that's not what I want to do. I know what I'm going to do. I'm going to create a private method, private void print score. And in this method, I want to print the score, right, for each opponent, whoever has whatever the score is. So if this dot get points equals 40, and this dot opponent dot get points equals 40 as well, then I want to say system dot out dot print line deuce. All right. And the whole reason I'm doing this, and I actually don't have to continue this example because it kind of accomplished what I was trying to do. The whole reason I'm doing this is to show that since I made the score method in my athlete class abstract, it's up to any class that inherits athlete to implement it. So inside my basketball player, I provide public void score at override, and the basketball player's score method is a little bit different. Inside my tennis player, this is what I was working on, this is a lot different as well. So when a tennis player scores, I want to add, they go from, the scoring system goes 0, 15, 30, 40, deuce, or whatever it may be, if the opponent has a 40. So if that's the case, their scoring method is completely different than a basketball player's score method, all right? And that's what I was trying to get at. And I know I was kind of going down a rabbit hole right here. But just to say that abstract class, if you have an abstract method, then that score method, or whatever method it is, has to be implemented by any subclass, all right? Any questions? And I'm going to do a whole different example if there are no questions.